Here we will be looking at multiplying polynomials, kind of like what we did with the distributive property, but we'll look at how to do that with more terms. So just a quick review. Remember the distributive property, multiply each term. So that would be 12x squared plus 3x. And in the next one, that would be 8x plus 2. And the reason why I'm reviewing this is because if you look at this next example, see how here we had the 3x and the 2. We're actually going to be doing that in order to do that same multiplication. In other words, it's like a double distribution. To do this, you multiply the 3x by both terms, and then you multiply the 2 by both terms, exactly like what we had done up there. And then we combine them. So if I do that, that's going to give you 12x squared plus 3x plus 8x plus 2. It's just doing both of those distributions that we did here and just combining them. And then so the two middle terms can be combined. So that would be 12x squared plus 11x plus 2. All right. And then there is kind of a little follow-up here. What if the sign was different? What if it was 3x minus 2 times 4x plus 1? So notice the sign's different. Essentially, it's still the same. It's just that you're multiplying by a negative 2 in there. So the first part would be the same, 12x squared plus 3x. But then notice this time it would be minus 8x and minus 2. So those middle terms, when they combine, would be slightly different. 12x squared minus 5x minus 2. And this technique here, you might have seen this before. A lot of schools teach this FOIL method, because if I highlight it, here I'll just kind of draw this out. If you said, like, say, x plus y times w plus z or something. The first one would be the first terms, and then the outer terms, and then the inner terms, and then the last term. So FOIL, first, outer, inner, last. So it's just kind of a way to do it. And then I learned this one later, the claw. It's kind of funny. If you look at this shape that we had up here, it kind of looks like a claw pinching. So it's just kind of funny to see that shape as a claw method, like a lobster claw or something. So just to kind of see that, if it was w plus z, right? I'll do the claw. I'll do red for a lobster, right? You got the claw. You got the top part of the pincher and the lower part of the pincher. Kind of a silly thing, but a nice way to remember it. All right, let's go through a couple more examples just to practice. Let's claw our way through here. So x times 3x squared, 3x cubed, and then the next one, x times 8, so plus 8x. And then the inner terms, that would be negative 21x squared. And then the last terms, minus 56. And doesn't look like we have any like terms in this case. So our answer would be done here, or you could rearrange it in descending order, but this would be perfectly fine. Here's another one. Let's go 5 times x would be 5x. 5 times negative 4 would be negative 20. Negative x cubed times x would be negative x to the fourth. And then the last one, notice that would be a negative times a negative, so plus 4x cubed. All right. Now, one last example, and this one you might notice is like a triple distribution, okay? The concept's the same. You're going to start by multiplying the first one by each of those terms, okay? So this one's going to get a little bit of a messier attempt here. May take us a few more steps, but it's all good. X squared times 3x squared would be 3x to the fourth. Remember, you're multiplying, and therefore the exponent changes. Then the next one would be plus 2x cubed. Then the third one would be minus x squared. So that takes care of all those blue markings. Now we got to do the middle term by all three. Okay, so x times 3x squared would be plus 3x cubed. Then x times 2x would be plus 2x squared. And then the last one would be minus x. All right, so we kind of have a triple claw, but now we have a triple claw. So this last term has to distribute to all three as well. So this is the part that gets a little bit wild. I'm running out of space. Let me zoom out for a moment to squeeze this last part in. So 1 times 3x squared would be plus 3x squared, and then plus 2x, and then minus 1, because here you're just multiplying each of those by 1, so not a whole lot changing. All right, let's find our like terms. X to the fourth, oh, looks like that's the only one, so I'm going to check it off. I don't want to cross it out, but let's say check. 3x to the fourth, got that one. Let's get our x cubes. So x cubed, we can combine those two. So 2 plus 3 would be plus 5x cubed. Notice the exponent doesn't change here because I'm just adding, not multiplying at this step. Then we got our x squareds. There's a few of them here. There's an x squared, there's an x squared, and there's an x squared. So that would be negative x squared plus 2x squared. That would be positive x squared. Plus 3 more, so plus 4x squared. Now we need the x's. Looks like there's those. So that would be negative x plus 2x would be plus x. And then finally the constant term minus 1. So same idea as that claw or foil method. It's just extended, kind of a tripleized version of that.